Hey guys, welcome back to part 2 of our slope notes. Today we're going to be talking about some rate of change when we get to the next few problems, but the first few problems are going to just be a little bit of reviewing from our first part of the notes. Graph the line that contains the point -3, 0 and is perpendicular to the line that contains these points. Perpendicular, we're thinking opposite reciprocals. So first we need to find our slope of these two given points so we can find the perpendicular slope. So we have 0 minus -3 over 2 minus -2. Remember that the minus and negatives are going to turn to plus positives. So we get 3 over 4. So our perpendicular slope, remember the little upside down t represents perpendicular, slope is going to be the opposite. So it was positive, it's going to become negative, and now we're going to flip our fraction. Let's go ahead and graph that. It contains the point -3, 0. And now we're going to do our slope down 4 over 3. And we can also go up 4 and over 3. Now we have graphed our perpendicular line. Now I can graph the other 2 points, 2, 0, and -2, -3. And the lines are going to be perpendicular. So that means that they're making that right angle. All right, let's go ahead and check out this next one. It says graph the line that contains the points 5, 1 and is parallel. This time we're thinking parallel. Okay, parallel means we're going to have the same slope. So x1, y1, x2, y2. So we're going to take 1 minus 4 over 2 minus -2. Again, turns to plus positive. So we get -3 over 4. Parallel, that's those two little parallel lines. Parallel slope, remember, is the same slope. So we're going to be using that -3 fourths slope again. So we're going to use our 0.51 over 5 and up 1. And now we're going to go down 3, 1, 2, 3, and over to the right 4. Oh, that takes us off our graph. So remember that we can change where that negative symbol is. Oh, we can change where that negative symbol is, and it's still going to stay the same. So we can instead, we can go up 3, 1, 2, 3, and we can go to the left 4. 1, 2, 3, 4. We can go up 3 and to the left 4. All right, so there's my new line. If I was to graph my first line, I had -2, +4, and we had +2, +1. Those two lines are parallel. All right, so just practicing using our parallel and perpendicular slope. All right, rate of change. Rate of change happens a lot in application problems. The slope can be thought of as rate of change. The rate of change can be used to describe how the quantity of y changes to a quantity of x. So honestly, we're thinking about this just like slope, but rate of change is going to be more real life situations. So in 1965, the city of Columbia, South Carolina has a population of 8,052 people. In 2012, it was reported that the population was 131,686. What's the annual rate of change? Annual says that we're going to break it down per year. So we actually want to think about this like an ordered pair. 1965 had a population of 8,052. 2012 had a population of 131,686. So we're going to think about that just as if we were thinking about our slope. x1, y1, x2, y2. So we have 131,686 minus 8,052 all over 2012 minus 1965. So if you were to do that on your calculator, we'd get 123,634 divided by 47. But it asks us for annual. So that means we need to make the bottom number a 1. So if we take 123,634 and divide it by the 47, we are going to get 2,630.5 per year. Now we're talking about people, so we don't want a decimal place when we're talking about people because people are a full thing. So then we can round this one up to 2,631 people per year. So approximately every year, they gained about 2,631 people. All right, so number 6 says, in 2013, 500 million songs were legally downloaded from the internet. In 2011, 200 million songs were legally downloaded. Find the slope and interpret the meaning. Same idea, rate of change, slope. So we're going to, again, put them into an ordered pair. You don't have to write out all the zeros for 500 million. We'll just take million on as a label at the end. All right, so go ahead and find that slope. So pause the video. When you come back, we'll talk about the slope. All right, so you should have about 300 over 2. Well, we're again going to divide those because we're going to talk about per year. So we have about 150 million, there we're going to put that million back in, songs downloaded per year. B says, if this trend continues at the same rate, how many songs will be legally downloaded in 2015? All right, well, we've got to think about there's 150 million songs downloaded per year. In 2013, there were 500 million songs downloaded. So we're going to take 500 and we're going to add, well, from 2013 to 2015 is 2 years, and there's 150 million downloaded per year. So we're going to times that by 2. So we end up with 500 plus 300. So we are thinking that there's about 800 million songs, oops, there's million songs per year in 2015. Okay, I want you to go ahead. There's problem 7, obviously not on my smartboard, but problem 7, I want you to finish that up in the notes and bring that back for class the next time I see you.